Welcome to The Explainer. Today, we're unpacking one of the absolute highest stakes topics on our planet, Earth's ice sheets. They're massive, they're ancient, and they are deeply connected to the climate stability that we've enjoyed for literally thousands of years. But scientists are observing a steady increase in ice loss driven by human-caused climate change. So today, we're taking the data from our sources, and we're going to explore a rapidly accelerated future. Okay, let's dive right into this. What if Earth's ice sheets melt twice as fast as today's projected rates? Just imagine it for a second. We aren't just talking about more water here. We are talking about fundamentally altering Earth's entire climate system, accelerating sea level rise, ramping up extreme weather, and severely challenging our global society. The sheer scale of this scenario is exactly what we are mapping out today. You know, when we talk about melting ice, the true danger isn't actually just the final volume of water, it's the clock. As our source material points out so perfectly, societies can adapt gradually to slow environmental change. Rapid change is far more difficult and expensive to manage. Basically, a faster rate of melting means way less time for us to adapt, faster coastal changes, and much greater economic disruption. But to truly understand this massive global ripple effect, we first have to look at the source of the drop. Section 1, meet the ice sheets, Earth's glacial giants. And this brilliantly illustrates a really common misconception. People so often confuse sea ice with ice sheets. Sea ice forms when ocean water freezes. Because it already floats in the ocean, melting sea ice is just like melting ice cubes in a glass of water. It contributes very little to actual sea level rise. Ice sheets, on the other hand, they are enormous masses of glacial ice resting entirely on land. When they melt, they add vast amounts of brand new fresh water directly into the oceans. And when we say enormous, we really mean it. Nearly 99% of all the freshwater ice on Earth is locked up in just two major locations. Those two spots are Greenland and Antarctica. Now, Antarctica absolutely dwarfs everything else. It holds a staggering 90% of our planet's ice. The Greenland ice sheet, along with literally all the other mountain glaciers in the entire world, make up just that remaining 10%. To put the sheer scale of Antarctica into perspective, if the Antarctic ice sheet alone were to melt completely, which by the way is a process that would take centuries under sustained warming, it could raise global sea levels by an unfathomable 58 meters. That's 190 feet. That is roughly the height of a 15-story building. So what actually happens if we hit the fast forward button? Section 2, doubling melt rates. Faster melting impacts. Now, what's really interesting about this process is that the most dangerous melting actually happens completely out of sight. Relatively warm ocean water can flow right beneath floating ice shelves, basically melting them from below. When this warm water reaches a glacier's grounding line, especially in places like West Antarctica, where the bedrock is actually below sea level, it triggers a self-sustaining and super rapid retreat. Scientists call this marine ice sheet instability. It acts kind of like an invisible gear, just relentlessly grinding away the ice from the bottom up. And as that ice retreats, it kicks off what's known as the ice albedo feedback loop. Normally, fresh, bright snow reflects sunlight back out into space, right? But as that bright ice melts, it exposes the much darker ocean water below. Because it's darker, that water absorbs way more solar heat, which in turn causes even more ice to melt. It's this crazy runaway, self-reinforcing cycle. When you combine those warmer oceans underneath and an accelerated feedback loop on top, well, the impacts definitely don't stay confined to the poles. Section 3, global ripple effect. Impacts beyond poles. The most immediate consequence of melting twice as fast is, of course, faster sea level rise. And this directly translates to catastrophic coastal flooding for the world's most populated cities. We're talking about severe existential risks for New York, Miami, Shanghai, Jakarta, Tokyo, and London. Faster sea level rise means permanent inundation of low-lying neighborhoods, flooded subway systems, and just immense pressure on global infrastructure. That severely disrupts global commerce and supply chains, heavily impacting even those of us living far inland. But hey, the threat isn't just the water we can see above ground. There is a whole invisible crisis happening right beneath our feet called saltwater intrusion. As sea levels rise, seawater is literally pushed inland into rivers, wetlands, and critically, into our underground aquifers. This completely contaminates our drinking water and poisons the fresh water that we desperately need for agriculture. So the crucial point here is that we aren't just raising the water level, we're actually altering the chemistry and the flow of the oceans themselves. Trillions of gallons of fresh water dumping into the North Atlantic can reduce the density of seawater and weaken the AMOC, that's the Atlantic Meridional Overturning Circulation. Think of it as Earth's critical climate regulator. Weakening it cascades into changing European temperatures, altering monsoon systems and rainfall in Africa, reducing marine productivity, and totally shifting how hurricanes develop. And obviously, human cities aren't the only ecosystems at risk here. Up in the Arctic, polar bears face reduced sea ice, heavily limiting their ability to hunt. Down in the Antarctic, changing sea ice disrupts the early life habitat for krill, which are quite literally the foundation of the Southern Ocean food web. And even far from the poles, global oceans are experiencing intense marine heat waves that trigger devastating coral bleaching. The whole system is connected. When you combine all of this, flooded cities, contaminated drinking water, failing agriculture, you get a deeply human socioeconomic impact. Climate migration, accelerated ice melting, and the resulting extreme weather will absolutely drive the inevitable massive displacement of global populations as vulnerable livelihoods are completely wiped out. Let's move to and see how this builds over time, because understanding when these changes happen is just as important as knowing what they are. Section 4. Tipping points, thresholds of no return. Based on the science, our timeline looks roughly like this. By 2050, continued sea level rise and coastal flooding are locked in. That's going to happen regardless of immediate emission drops, mostly because the climate system responds pretty slowly to past greenhouse gases. But look at 2100. The severity of higher temperatures and infrastructure risks by then is heavily dependent on the human decisions being made right now. And looking beyond 2100, we are facing centuries of long-term ice sheet adjustments that will reflect those very same decisions today. Which brings us to a somewhat terrifying but absolutely necessary concept to understand, the climate tipping point. This is a threshold beyond which a system undergoes substantial change that may be incredibly difficult or even completely impossible to reverse on human timescales. Scientists are incredibly focused on whether regions like the highly vulnerable West Antarctic ice sheet could cross this threshold, permanently committing us to long-term mass loss. Now, while these projections are incredibly serious, future outcomes are not fixed. Section 5, slowing down the melt, mitigation and adaptation. First things first, we have to address the root cause, and that means mitigation. We just have to stop adding heat to the global system. This means rapidly transitioning away from fossil fuels over to clean energy, stuff like solar, wind, and hydropower. It means aggressively improving our overall energy efficiency, fiercely protecting our forests so they can continue to act as natural carbon sinks, and adopting much more sustainable agriculture practices. But because some continued warming is already locked in, we also must prepare for change through adaptation. Proactive investments, and yeah, they are really expensive up front, are entirely necessary to survive the melting that's already unavoidable. We're talking about building seawalls and restoring wetlands for coastal protection, designing totally climate-resilient infrastructure, managing our water resources through advanced recycling and desalination, and deploying robust early warning systems to give communities actual time to respond to extreme events. The reality we've unpacked in this explainer today is pretty clear. The ice is already melting. Accelerating that process would compress decades of required adaptation into just a fraction of the time. The decisions we make right now regarding our energy systems and global cooperation, they will literally dictate the map of the world tomorrow. So the ultimate question isn't really whether the ice will melt, but rather, how much time will we buy ourselves?